The last type of force we learned today is gravitational force. Gravitational force is a non-contact force. Gravitational force, or gravity, is a force of attraction between any objects which have mass. Earth's gravitational force pulls objects towards its center. This gravitational force on an object is called its weight. Weight equals mass times acceleration of gravity. The SI unit for weight is Newton. On Earth, the acceleration of gravity is approximately 10 meters per second squared. It is important to remember that weight is not the same as mass. The weight of an object and its mass are directly proportional. The same object can have different weights at different locations if the acceleration of gravity is different. At the same location, the greater the mass of the object, the greater its weight. Weight is a force, and it can be measured by force meters. For example, extension spring balance and compression spring balance. Let's take a look at some examples. Calculate the gravity force, or weight, of a skydiver with a mass 70 kilograms falling towards the Earth. A team of astrophysicists sends a probe to Jupiter. The acceleration of gravity of Jupiter is 27 meters per second squared, and the probe is 1,200 kilograms. Calculate the gravity force, or weight, of the probe on Jupiter. This chart shows the types of force we learned today, and their categories. The next topic we discuss today is pressure. Pressure is the force exerted per unit area. The SI unit for pressure is Pascal. 1 Pascal equals 1 Newton per meter squared. These are the methods to reduce pressure. Decrease force applied. Increase the area on which force is applied. There are many cases in our daily life where high pressure is useful. For example, cutting. A sharp knife has a very thin cutting edge, so the force of our hand applies on a very small area of the object, producing high pressure. This high pressure cuts the object easily. When sewing, the sharp needle tip applies a very high pressure onto the cloth, allows the needle to poke through the cloth easily. When hammering nails into wood, the sharp tip of the nail applies a very high pressure onto the wood, allows the nail to pierce the wood. The studs on the soles of soccer boots, and spikes on the soles of a runner's shoes, create high pressure on the ground, so that the studs and spikes are lodged onto the ground, providing grips. There are also many cases in our daily life that low pressure is more useful. When walking or moving on soft snow, we need large snowshoes, which have large surface area, so that the pressure is lower, and the shoes do not sink deep into the snow. Although tractor is heavy, it doesn't sink onto the soft soil of the field, because tractor has large wheels, lessen its pressure on the ground. Next, we discuss about two special types of pressure, atmospheric pressure, and pressure in a liquid. The atmospheric pressure is different at different altitudes. Atmospheric pressure decreases as the altitude increases. For example, when drinking from a straw, the air inside the straw is at lower pressure than the atmospheric pressure on the water in the cup, so the water is pushed up through the straw. How do suction cups work? Do you think suction cups can work in outer space? The pressure in a liquid is different at different depths. Liquid pressure increases as the depth increases. For example, the pressure acting on a dam at the bottom of a reservoir is greater than the pressure acting near the top. This is why dam walls are usually wedge-shaped. It is thicker at the bottom. Every submarine has a depth limit. When the submarine dives beyond this depth limit, the water pressure will crush the submarine. This is the summary of what we have learned today. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye. This is the summary of what we have learned today. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye.